Hey everybody, this is Jim Neeb again from Jim Neeb Woodworks. I thought I'd do a little update today on my RapidChange ATC that I got recently. I did a quick video a while ago showing just some basic tool changes, and now we've got the macros from RapidChange that are pretty robust. They're at a point where I can actually run a full flow. So I thought I'd just do a video. This is kind of a first impressions look at the things I've noticed and what I've gotten done on it so far. I still have some testing to do for to make sure that the torque is adequate, and also some reliability testing to see how often it fails and stuff. And then a lot of people are concerned about cross-threading damage. You know, if it doesn't thread onto the nut properly, does it do damage to the threads and stuff? So I want to do some more testing there as well. So I'm going to do this video as kind of a preliminary first findings, first review, and then I'll follow up in a couple of weeks with some more data. I plan to do a bunch more torque testing and just repeatability testing. So this is kind of going to cover what this unit is, how it works, and give you a look at what a full G-code file execution with a few tool changes and stuff looks like. Okay, let's go over the RapidChange unit itself a little bit first and see how it works. So basically you get it's called a cartridge or a magazine. This one has 6 positions and it holds the collet nut, the collet, and the bit. And so similar to the other style of ATC that has a collet nut on a tool holder with the bit, this has less expensive components duplicated. You just need a nut and a collet for each one of the tools that you want to place in the magazine. And I believe they have 4, 6, and 8 position magazines. You could put multiples on a machine if you really wanted to. You can see this one, these are pretty small. I only have a 4x4 machine. This doesn't take up too much of a footprint. It has a lid. You can buy versions with or without lids. This one has the automated lid, so through a G-code command, I can open the lid. So now if you look down inside, basically you see there's 3 little ball bearings embedded in the plastic housing, and that's what grips the nut. So essentially what happens is to load a bit and collet nut on the spindle is brought in above here, turned on at a very low RPM, and then lowered down at the same rate that the threads would thread on that nut at that speed. So essentially it threads on to the spindle, then it backs off and is reinserted in there and grips again. And essentially it's the momentum of the spindle mostly that gives it the torque to lock it on. So it's dropped in there, and essentially that nut is grabbed by these 3 ball bearings and prevented from spinning. So the momentum of the motor works against that nut that's held still, and that's what torques it on. And essentially it stalls the motor for about a second, and then it's retracted, and then it just does the reverse to take the nut off. That's why you need a spindle set up to be able to reverse and do an M4 command. So it just spins it off, and it has an infrared sensor, transmit and receive. I believe that's also an option. So if you don't get the one that has the lid or any of this top piece, it doesn't have the IR sensor either. But that IR sensor is used to tell if it's lifted up. So basically it does a check first to make sure that the nut blocks the beam, and then it comes up just above where the nut should be screwed on tight to see that the nut has been threaded on properly. So it can tell if there's a nut picked up at all, and then it can tell if the nut's been correctly threaded on. So if it cross threads, this IR detector will catch it, and so then the software obviously will throw an error and stop. And I've tested this several times. it works very well. It will definitely catch a cross-threaded nut that didn't screw on all the way. You can notice this little piece of heat shrink tubing that I have on here. I put that on because I have these large garage doors in my shop, and when it's daytime and I have those open, I get too much infrared radiation coming in from outside, and it actually floods this receiver out. And so even if the beam is blocked from the transmitter here, it won't trip the sensor because there's enough IR flooding in here to keep the sensor active, so it doesn't actually work well. It works fine if I close my door, and it works fine here at night with the door open, so it's not going to get any interference from your shop lights, but from outside it will. So this tape just kind of makes it a little tunnel into there, or this, sorry, not tape, the heat shrink tubing just kind of makes the little tunnel in there for the light can only come in straight from here, from the transmitter into there. So once I put that on, I can run this fine all day long with the outside doors open in a bright sunny day. One thing I should note is that the RPM of the spindle is very important. This system works best, I'm told, in the range of about 1200 to 1500 RPM for an ER20 collet. Basically, the smaller the collet, the faster the RPM. And when you go up to ER32, I think they're doing like 1000 RPM or something. And that's just related to the bigger the nut and spindle, the more torque you're going to get, because the motor mass is bigger already, typically for a spindle that has a large collet. So it's kind of proportional to that. But you do need to make sure you get your spindle dialed, and you got to get the spindle set up to do reversing, obviously, to unlock the nut. And you also have to, sometimes in the case of the AVID machine, I had to go reprogram the VFD so that the lower limit that was programmed in there is lower yet, because AVID programs it to like 30% of the max speed, which means I can't go below 6,000 RPM. I actually thought I didn't realize I was running that fast, and I damaged the first 3 sockets here. This is why I got to get new parts for these. That's why I'll be demonstrating using the back 3. So again, you want to verify the control of your RPM down to probably about 1000 RPM is good enough. You don't need to go below that, but that's important before you actually start using the rapid change. So I think this ATC system kind of fits a niche. I don't want to call it a poor man's ATC, because it's really not. I think it does 95% of what a typical ATC does. But the cool thing is, this will work on systems that a lot of spindles, or a lot of CNCs out there, you simply can't buy a spindle that has the tool holder, the drawbar and the capability to take a standard tool holder. Like I have just a standard spindle here, and if I wanted to put a regular ATC on, I'd have to go get a new spindle, all those tool holders. I'd have to allocate more space somewhere on my system. This one comes in a bunch of different sizes. It works with a standard spindle, and a lot of the configuration and setup, I think, are much easier. And the other thing is, this thing is way cheaper. You have to buy a few extra collet nuts, but most people probably have a nut with each one of their collets anyway. But you don't have to upgrade the spindle. You don't need all those tool holders. So and the magazine itself is very reasonable. I believe this one with the IR sensor and the lid, the 6th position, I believe that's around $600 or something. So, that's really all you're into it. And then they provide a full software solution as well. They have all the macros. They provide the graphical screen plug to go into, your Mach 4 screen set to, that's not available yet, but they have provided that for the other machines that they're supporting right now. So, you know, I think it's a very capable system. It's the only system that'll work on some CNCs, but even on mine, I would never, I don't need a ATC bad enough that I would ever consider a full-blown ATC and upgrading my spindle. I like the spindle I have, so this one really fits the bill for me, I think. Another thing I should mention is that the RapidChange system is limited in diameter of the bit by the center holes down here. So if you see, this is a 1/2 inch end mill, so we can do about a 5/8, maybe slightly bigger bit in this. An ER32 collet system probably could do 3/4 of an inch or something. These holes in here are kind of proportional to the size of the collet nut, because there has to be enough material to hold the collet nut in there. So there's somewhat of a limitation compared to the tool holder type ATCs, but on the other hand, I would venture to guess that 95% of the usage of with CNCs out there is probably you know, with 1/2 inch or less end mills anyway. So you can also do very long ones. You can see this is a pretty long one, and that's to have that length. You can see that the hole goes all the way through the RapidChange magazine, and then I've stacked up 3 layers of plywood and bored a hole in line with those, and that's what allows me to have the longer bits. You can also just simply make a cutout in your table underneath there and mount it lower if you don't want this sticking up so high. Lots of different options for mounting this. The software is fully configurable. You know, you can have this set either down your y-axis, down your x-axis. You program where the first pocket is in the spacing. You also program in the configuration where your tool setter is, or if you have a tool setter or not. There's a lot of configurability in the system. It's pretty nice. Where you put this is pretty flexible. You can mount it pretty much anywhere on your machine. I put it here because I already have kind of an unusable area on my table because of my rotary unit, and I keep my touch plate over here in a storage location, and so I'm going to use this standard AVID touch plate as my tool setter. Now, if you don't have that, or you have a different kind of machine, they do have a tool setter option that goes in this spot here. You can see the extra cutout for the wiring. So they do sell a tool setter that fits in there. It's an option as well. So, but what I'm going to show you is just use of the standard AVID touch plate as a tool setter. Okay, so there's kind of 2 ways to do tool offsets. Most people doing ATCs use what I call the master tool method, which is they'll use tool 1 or one of the tools in their assortment to be the master tool. And so what they'll do is get they'll call that 0 offset, and then all the other tools are measured relative to that one, and so there'll be a, you know, plus or minus length offset for all the other tools relative to the master, and the master is used to set the Z height. The other method is basically just store every single one of the tools as with its own raw machine coordinates for its length, and then the difference there is no tool is a master. And then when you run your Z touch off to set your Z height, all you have to do is enable the tool offset value for that tool first, and then run a Z touch off on one of the tools, and it doesn't matter which one. And then the math still comes out the same way. And then after that, when you're doing your changes, just the different tool offset by itself will give you the right Z height, because it's all relative, right? The problem with AVID machines or the AVID touch plate routine is they turn off tool sets in the AVID touch plate routine. So when you go to set Z height, it assumes basically that you don't have any tool offsets because it turns that off. So you have to use the master tool method with if you want to use the stock AVID touch plate routine, and they don't supply the source code, so you can't edit it. So RapidChange added that capability in here as well. So what that means is we just have to decide which tool is the master, and in their software is configurable. You can just say, and in my case, I'm saying tool number 4 is. So I'm going to first do a tool. In this, you're going to see me do a tool change to tool 4. It's going to probe it. Then I'm going to go set the Z height with tool 4. And then from there, I can run the whole G-code flow, because it's saved the value for that master tool, and now it can automatically switch to a new tool that's not tool 4 and do a new touch probe or tool setter probing of that new tool, and then continue on with the G-code. So that's kind of the process that we're going to show here in the next few steps. That little double step is where it's lifting up the chuck or the collet and checking first for the IR beam that the nut has been placed, and then it steps up a little bit forward to make sure the nut has actually threaded on completely. So if it cross threads, it will detect it, and I verified that a few times. So it's very good about not proceeding if the nut hasn't been properly loaded onto the spindle shaft. So now we have tool 4 loaded. It's set it to 0 tool offset, but it's also stored the raw value of the position for the master tool. So now I can go and set my Z height. All right, my master tool is loaded. It doesn't necessarily have to be loaded first, but I just have it loaded yet because I used it to set the Z height. My X and Y are set, so we can run the file now. So this particular G-code file does not start with the master tool, so it's going to put it away. And tool 5 happens to be the first one. So it's going to go over and probe itself. Looks like I almost have my ground wire in the way. It does a double tap probe, so it comes in fast, finds the position, and then retracts a little bit and does a slower probing. Spinning in reverse, unloads the tool 5, going to load tool 6. This reminds me why your dust collection is important. That last operation really made a lot of dust. Now we have a V-bit loaded. Now all these approach speeds can be adjusted in the configuration file. I just happen to be set it pretty low speed yet because I'm still testing. And one last thing, we'll drill a couple of holes. And that's it. So 3 tool changes. If you want, you can mess around with your post processor to put that last tool away if you want. There's all kinds of options. Just the M6 command to do that. So what we have today works very well. I'm using basically just the MDI window to play around with this, or a G code. They are working on a full Mach 4 screen set to kind of make it easy to do all your configuration through buttons and everything. And then obviously there'll be buttons to load and unload tools and everything, so you won't have to use the MDI window. But honestly, once you kind of remember the commands and everything, the MDI is very convenient as well. You almost don't need any kind of a fancy GUI, but that is coming. So I'm going to finish up. I still have to do more torque testing. What I'm trying to do is, do a load and then measure the torque, and do a load and measure the torque with a bunch of different collets just to kind of see what the average is. And then I want to do some heavier load testing. The torque values are not as high as you will get when you're hand tightening, but all the testing so far from other people indicates that it's enough torque to hold the bit without slippage, and that's ultimately really all that matters. I'm going to do some load testing with some big long end mills that tend to work their way out if they're not torqued adequately, so we'll see how that goes. And then the other thing is just to see how reliably it can pick these things up. I have had a couple of cross thread incidents already. Neither one has put even a scratch on the thread. So the very low RPM of 1200 to 1500 RPM for the E20 collet just simply isn't enough speed and torque to do any damage so far that I've seen. The collets, they're the collet nuts, and the threads on the spindle shaft are very hard, and it just doesn't seem to do any damage at all. And the times that I have had cross threads, they seem to be a particular nut that I have, or a nut collet combination, where the either the thread isn't very good on the lead in, or the collet isn't sitting very straight, so as it inserts it tends to pop the nut up a little bit. So I've started to weed out the bad nuts in my set here, and that seems to have taken care of the problem. So I'll have another follow-up video with the final testing and my final thoughts on, like if there's any problems, or all, if this seems like, you know, a good robust solution. But so far, I haven't seen any concerns really. So to me, so far the price point, the value that this has is very good, and I think this is looking like it's going to be a pretty good alternative for people who don't want the full size and the full cost of a traditional ATC. This is a pretty easy install, and so far their software has been working great too.
All right, I think that gives a pretty good overview of the RapidChange system itself, what the tool change process looks like, and everything. As I said, I've still got some testing to do. Probably in a couple of weeks, I hope to have all of the torque and repeatability testing done, just for more confidence. Really, I'm pretty happy so far, but I do need to do some load testing and things yet. And I'm hoping that the graphical user interface might be ready by then, so I could actually show that too. So we'll see. Again, I'll post a final review on here. So if you have any comments or questions, feel free to enter them below in the comments section, and I will also put a link to the RapidChange website in the description section. Thank you for watching.